Hi, I'm Michael Brown, reviews editor at Maximum Tech Magazine. I'm here today to talk about the exciting world of digital cables. A common misconception about digital signals is that they're an all or nothing affair, that you'll either get a perfect signal at the receiving end or you get nothing. While it is true that digital signals are more resistant to interference, a cable like this Ethernet cable, a signal can travel about 300 feet without having to worry too much about corruption. That's not the case with HDMI signals. They are much more susceptible to interference, and they have a tough time going long distances. About the longest you can run a very good quality HDMI cable is about 30 feet. I have one in my home theater that goes from my receiver to my ceiling mounted projector. It's a 32-foot cable. I couldn't go much beyond that without having some type of signal amplifier in the path to boost the HDMI signal. So I'm going to show you several different HDMI cable solutions today, and then we'll talk about a new type of cable that is pretty damn cool. Now personally I tend to prefer thick cables like this XL HDMI cable just because they seem more robust, they're stronger, they have thick reinforced collars at the connecting ends, and they just seem well designed and well constructed. But even a thick cable like this is not going to be good enough to send an HDMI signal a long distance. This is about a 10-foot cable. That's pretty typical for what you'll find on the market. It's a good cable, nothing wrong with it. The only problems is that a thick cable is not very flexible. That's about the most turn you can make with a thick cable without worrying about kinking it. You kink the cable, you might as well throw it away. This is especially problematic when you're dealing with devices in a small entertainment center. If you don't have a lot of room in the back to make a tight bend, again, you kink the cable, you might as well chuck it because it's useless. XL did come up with a clever solution to the kinking problem and the tight angle problems. They came up with these HDMI cables that pivot. It'll pivot up and down 180 degrees, and it'll also swivel 90 degrees. So if you have a tight spot where you want to put a device, you can put this in there, and it takes up a lot less room. You don't have to worry about kinking the cable. It's still thick, however, and it still won't go a very long distance. So if you have like my home theater, I have a projector in my ceiling. I have an XL cable in the ceiling. It's about 32 feet. That's about as far as it will go without some kind of amplification to the HDMI signal. Here's another clever HDMI cable solution. If you have a device in your entertainment center like this Blu-ray player, and your HDMI cables keep coming disconnected because you pull the device out to clean around it or what have you, this company called Perfect Path Connectivity makes a locking HDMI cable. It actually locks to the inside of the HDMI connection, and it won't easily pull out. You have to push this button on the bottom to release the cable to disconnect it. The problem with locking cables is that if you tug too hard on the cable, it can actually damage the HDMI connector inside because it doesn't release properly. And again, this is another passive solution, so you need a fairly thick cable that's well protected with braiding. Again, not very flexible, and you have issues with length. It can't be very long because the signal won't traverse that long of a path. We've talked about several different HDMI cable types that have solved different problems. One thing they all have in common is that they're passive cables. So obviously the alternative to the passive cable is an active cable, and that's what I'll show you now. An active cable actually has a chip in the end of the cable that you plug into your device, into your TV, your display, your AV receiver. And it has a chip inside that amplifies the HDMI signal and equalizes it. It runs a test measurement on the HDMI signal, identifies which signals are too weak, which frequencies are too weak, and it automatically boosts those signals and equalizes them so that the signal stays in HDMI spec. Because the signal is amplified, the cable can be a lot thinner. It requires a lot less copper. It can be more flexible, and it can be longer. This cable here is made by a company called Redmere. They're the company that actually makes the chip. They tell me the longest cable they've seen so far is 145 feet long, with no other amplification other than the chip that's in the cable. So it's thinner, it's more flexible, requires less copper, and eventually, they're more expensive right now, but eventually they will become cheaper than passive cables because less raw materials are used in their manufacture. You don't use as much copper, you don't need as much shielding around the copper, you don't need as thick of a jacket, so lots of benefits. Flexibility, length, robust signal, currently a little more expensive. This is a cable from PNY that uses the Redmere chip. You can see the difference in the thicknesses of the cable. Passive cable, active cable. This is Redmere's newest design, which is even thinner. It's about 1/8 of an inch thick. So active HDMI cables solve a lot of problems, and they perform just as well as traditional cables. So, all right. Well, I hope you enjoyed this talk on HDMI cables. There's nothing the geek likes to talk about more than cables. So, thanks for watching. This is Michael Brown. We'll see you next time.